Okay, good morning, Science 10s. Before the holidays, we started on ticker tape, and I did this little demo in class. And so you have a bunch of graphing analysis to do. And just to kind of make sure you're understanding the instructions, there was quite a few people who were away. So here's our ticker tape demo activity. And we sat down and we came up with a little hypothesis. If an object is in uniform motion, then the dots on the ticker tape will be evenly spaced apart because the object is changing its position in equal amounts per unit time. So the deal is, what is the ticker tape? Well, here's a little video that shows this little ticker tape or spark timer. So if you were here for my demo the other day before the holidays, this is a little device that puts a little dot on a piece of paper, the ticker tape, at a certain time interval. So here we see the little ticker tape timer. And then we are going to see this is the ticker tape itself. And so every time the little dot is placed on the ticker tape, that shows us how often the time is occurring. So I didn't have a little fancy card like this, but I took and I threaded the ticker tape through the little spark timer. And all I had was just a plain little physics card. And so not a little fancy card like this. Anyways, all you do is you attach it on like this. Now it's going to start. See that sound? That's the ticker tape. Okay, so each time the ticker tape puts a little dot, you can then use the ticker tape to analyze the type of motion that we get. Okay, so what kind of diagrams do we get? Well, here's our little piece of ticker tape. The little dots are indicating how fast an object is going. So if the dots are closer together, that means that the object is going in slower motion than if the dots are further apart, right? There's more distance, but it's the same unit time. And so we can clearly see here that each of the dots are evenly spaced out, but they're close together. Whereas here we've got the dots evenly spaced out, but they're further apart. So both of these are showing uniform motion. So the dots are evenly spaced. Why is that? Because they're going equal distances in the same amount of time. We've got one going fast, one going slow. So what if it's not uniform motion? What do we expect to see if it's not uniform motion? Well, maybe it's uniformly accelerated motion instead. Accelerated. Oh, I'm completely spelling it wrong. Accelerated motion. Thinking that that's spelled wrong. Anyways, if it's uniformly accelerated motion, then we're not going to see equal spacing between the dots. So here, constant speed, this is uniform motion. There is an equal distance or displacement per time interval. We're not seeing that on this next little ticker tape. Here we see uniformly accelerated motion. And more acceleration means there is more distance or displacement being covered per each unit time. So the whole point of doing this was to be graphing out these changes on our little ticker tape demo. So to make things a little easier for you, I gave you guys the data tables. And so these data tables are given as table 1, position of the dynamics cart. I didn't have a fancy cart, just used a physics cart, over time. This is showing us uniform motion. We're going approximately equal distance, actually it's position, it's a vector, it's displacement, position centimeters left, 0 to 9.9, it's about 10 centimeters left per each time interval. The ticker tape is going, the little spark timer, each 0.1 seconds, it puts a little dot on the piece of paper. So you use the table 1 information here to do your ticker tape. You don't have to rewrite it out here. It's given for you. So use the information in table 1 to do these analysis questions numbers 1 through 3. And so that means you're going to have to plot out a position time graph or displacement time and use that data from the position in centimeters left versus what's going to go on the x-axis. So it's going to be the time. Okay, so this is a vector. Make sure you're showing your units, centimeters to the left. Plot out your position time graph. Make sure you've got your title. Follow all your graphing guidelines. And then do the following questions, again using table 1. You're doing question 2. What type of motion? Is it uniform or is it uniformly accelerated motion? Justify your reasoning, explain why, and then determine your slope. So you've got to use your slope of your line. Once you plot your line out, you're taking positions high up and low on the line, and use your formula, write everything out, show your work. Once you've completed that, then you are going to use table 3. Now, table 3 is on the back of this page. Okay, so here's table 3, all done out for you already. And in fact, they did a slope calculation for you already. And when you plot this one out, you are going to get a velocity time graph. So again, it's a vector. Velocity needs to have units, and also it has to have a direction versus time. And you will get a graph that is going to be a horizontal straight line. Okay, anytime we're doing uniform motion, it should be a horizontal straight line for your velocity time graph. Okay, so you're going to use this information. So this is table 3. It is on the back at the top of your handout, and you use this to do analysis questions 4 through 8. Okay, so in your graph, you should get a horizontal straight line. Then, once you are done those questions up to number 8, the next information that you're going to need is observation table number 2. Observation table number 2, that is on the front side of your ticker tape activities. If you back up to the front, at the bottom. So notice, this is now accelerated motion. So remember we said that if it was uniform motion, our graph is going to have equal distances between the points. Okay, but that's not what we're seeing. We are seeing accelerated motion. So look at these values. The time is going up in equal intervals, but the position is not changing equally. 0 to 1.8, 1.8 to 5.9, 5.9 to 12.7. So what's this ticker tape going to look like? It's not going to have equal intervals. It's going to look something like this. Okay, so there's not equal intervals. It's accelerated motion or uniformly accelerated motion. So you're using table 2 here to do analysis questions 9 and 10 in your ticker tape. And then once you're done those questions, you're going to be drawing out a position time graph. Okay, so you draw out your position time graph, and guess what? Because it is uniformly accelerated motion, it's not going to be a straight line. So when you plot out your position, centimeters left versus your time, I expect that you will end up with a best fit line, something like that. Okay, so your best fit line is going to be curved. And then finally, to finish up this booklet, and again, we will be going through this in class, you are going to use table 4. So table 4 is on the back at the bottom of your sample data. You've got this sample data. Again, you don't need to write it out again. You're just using that information to finish up the rest of the questions in this booklet. So again, where do we find that? Here's my ticker tape. Okay, not the front of the page, but the back at the bottom. So here's table 4. And so now I've found the slope by the rise and the run. And so I took the slope of the data that I used from my distance or displacement, time graph, and I'm finding velocity versus time. So what am I going to plot this out? This is the graph that I'm plotting out here. So using table 4, I'm doing velocity versus time. And again, this is not uniform motion. This is uniformly accelerated motion, and we're actually going to find a curve for this. So this is how you're going to calculate and do the questions, this graph, and then number 13, 14, and 15. The key is going to be posted for this. You can check your answer key, make sure you're doing it correct. Work together, help one another out. Okay, that is it. That is all. Have at her.